In this video, we're just going to be simplifying radicals that are not perfect squares. Some of them might be a perfect square just to kind of get us started, like number 3. Now I'm going to be doing the odd numbers, and then you can practice the even numbers on the other side. So let's try number 3 to begin. So what makes a perfect square? So these are all squares or square root signs. Because if you don't see the number out front, it's assumed that it's going to be 2. So we are looking for pairs. So when we go to look at your value, your term, we're going to be looking to figure out some factors. So things that multiply into 36. Now, if you already know what the square root of 36 is, that's awesome. But this is for just in case to get us started, what we might encounter in the near future. So after 1, we can try and divide by 2. So 2 times 18 will get us to 36. 3 times what? Or 36 divided by 3 is equal to 12. We could do 4, so 36 divided by 4 is 9, and we're getting there. And we'll do one more. 6 times 6 is equal to 36. So we're really interested in the pair. Now, when you find your pair, it's the pair that is going to be this value. Now, let's say you didn't know, which is what we're going to be doing soon, is that let's say you didn't remember that 6 times 6 is equal to 36, but maybe you could recall that 4 times 9 can get you to 36. Well, because it's all under a square root, we can actually break these two up as if we had multiplied them, right? But still under a square root. Then we can evaluate them separately. So the square root of 4 having its own pair of 2 and 2 will equal 2. And 9, again, having its own pair of 3 and 3 is equal to 3. We're multiplying these two, so 2 times 3 is equal to 6. So when in doubt, if you don't know the perfect square within it, you can still figure out, okay, well, what do I know about some of these numbers? Going with any sort of perfect square is going to be the best option. Now, a good one to try with that is probably 2 and 4. Now, let's take a look at 75. So 75, they're factors, right? 1 and 75, 2 and if you're trying to divide 72 by 2, you'll notice that you come up with a fraction, which is not what we're looking for. So only keep it nice and clean. Now, if you notice that 75 is divisible by 5, that should be probably one of the first ones that you go to. So we have 5 times 15. And then again, because we're talking about 5s, there's probably another 5 within it, right? So if we talk about 75 divided by, let's say, 25. Well, 3 times, oh, well, I missed one, right? 3 times 25, right? So where's your perfect square? Well, your perfect square is made up of 3 and 25. So the square root of 25 times the square root of 3. So the square root of 25 has its own pair, 5 times 5. So it's really 5 times the square root of 3. Now, let's say you totally forgot about 3 times 25, but you certainly jumped to 5 times 15 because you recognize that there's a 5 in it. So let's try that that variation. So we have square root of 15 times the square root of, actually, not even square roots. So if we did 5 times 15, right, still equaling 75, well, what do you know about 15? Well, 15 is made up of 5 and 3. And notice that you have this pair of 5s. So sometimes if you can notice, okay, well, I can't really take the square root of these like I did with this one. Well, then try and break it up. What do you notice about some of your other factors? So then this 5 comes out because it's a pair, and this one remains in the parentheses, or in the square root sign. Let's get some more practice. So let's say the square root of 80. So the square root of 80, right, some factors. 1 and 80, 2 and 40. Now, does 3 go into 80? No. However, 4 goes into 80, 4 times 20. And we can keep going. 5 would go into 80 because it is, it ends on a 0. So 5 and 16. And you certainly could keep going. You can say 8 and 10 if you'd like. But of your factors, you're looking for the biggest perfect square. So your biggest perfect square, the number with the pair, is going to be 16. So we can say this is really the square root of 16 times the square root of 5. The square root of 16 is 4, and the square root of 5 just has to remain as is. Now let's say you knew, okay, the first thing that popped into my head was 8 times 10 is equal to 80, right? Well, what do you know about 8? Well, 8 can be made up of 2 and 4, and 10 is also 2 and 5. Well, you have your pairs here, so that can come out and make a 2 on the outside, but you also have this 4, right? What's the square root of 4? And the square root of 5. Well, the square root of 4 is 2, and the square root of 5 has to remain. So you're back to 4 root 5. So in case you don't get the perfect square, again, once more, trying to break up with your factors to find some more perfect squares. Let's try it again with 8. So 8, 1 and 8, 2 and 4, and that's it. So your perfect square in it is 4. So you can rewrite the square root of 8 as the square root of 4 and the square root of 2. The square root of 4 is 2, and the square root of 2 will have to remain. Hopefully you're kind of just following down as you're going through. 32. So 1 and 32, 2 and 16. And if you already can recognize, okay, well, 16 is that perfect square, awesome. This is where you can stop and say this is the square root of 16 times the square root of 2, so 4 root 2. Now, if you're also thinking, okay, well, at least 32 I know can be 4 times 8. Okay, well, the square root of 4 is 2, and the square root of 8 we just worked on is really 2 root 2. So then you can multiply these 2 that are found on the outside to make 4. All right, let's do it again with some more, and we'll do some bigger numbers. So 125. So if you're thinking, okay, well, 125, it ends on a 5, and so I'm gonna go ahead and divide by 5. Well, 5 times 25 will give us a 125. And already that is your perfect square. So we can write this as the square root of 25 times the square root of 5. So this is 5 root 5. Now let's say that we were looking for a perfect cube. So we're now no longer looking for pairs as in 2s, but we're looking for triples. So 3 of the same number. So if you did it again and you did, okay, 5 times 25, but what if you knew 25 was 5 times 5? So if you can recognize, okay, if you're leveling up to cubed roots and fourth roots, you're just doing the same process, but you're trying to count however many of the same numbers. So 3 of these 5. So the cubed root of 125 is 5. And let's change 11. Let's do the same thing with the cubed root of 8. So pause the video and see what you come up with. Well, 8 is 2 and 4, and 4 is 2 and 2. So right there you have 3 of the same number. So that means 8 must be a perfect cube, which equals 2. Let's see. Yeah, we'll do just a couple more. All right, so we have 175. And again, if you're recognizing, well, 75 is another 5 times then 35. And let's say because it's a higher number, maybe you don't have a calculator on the test, but you can at least do a little bit of division, right? Well, what do you know about 35? Well, 35 is 5 times 7. So right there, you already have your perfect cube. So it must be that 25 times 7 is equal to 175, which it is. 25 times 7 is 175. But you don't need that. You just need to look for the pair. Doing it again, you have 9 times, I hate how I wrote that. 5 times 9. 9's a perfect square, so the square root of 9 times the square root of 5 is 3 root 5. Now your last one, we have the square root of 20. Well, 4 times 5. Well, the square root of 4 and the square root of 5 is 2 root 5. So hopefully that was a good little intro to these. If you're taking my class, make sure you know your perfect cubes and fourths to a reasonable degree.